All right, welcome back to the office. We want to take a quick look at section 6.8. And in section 6.8, we are considering indeterminate forms and L'Hopital's rule. Let's see here. You'll find some various representations of this. This is that's not quite written right. Should be L'Hopital's rule. I think there are different ways that it's spelled, some with or without the S, but it should be L'Hopital's rule, essentially. Anyway, let's see. So if we want to talk about indeterminate forms, what we're referring to is limits. So when we're taking limits, we have seen some very nice indeterminate forms of 0 over 0 or infinity over infinity. And we've talked a little bit about how to handle those. Those are always appearing when we're looking at the limit definition of derivative, because we're always going to get that 0 over 0. So we perform some algebraic manipulation, so that way we have cancellations and we can actually evaluate the limit. So we want to continue taking a look at limits in this section as well. So again, we are talking about limits here. So we want to first say, okay, what's an indeterminate form? And again, we have seen some of them already, but we would also like to consider a few new indeterminate forms, things that we will now encounter and manipulate accordingly. So let's see here, one new form, 0 times infinity. That's kind of weird, right? 0 times anything is 0, but infinity times anything is infinity. So what happens here? Right, it could go to infinity, it could go to 0, it could go to some finite number. Don't know. Same thing here, 1 to any power is 1, but when we think of limits, right, it's not actually something that's 1. It's usually approaching 1 from the left or from the right. So if it's less than 1, anything less than 1 raised to the infinite power would give us 0. Anything larger than 1 raised to the infinite power would be infinity. So what are we getting here? 0, 1, or infinity, or some other finite number. 0 to the 0th power. This one is a little bit weird. Again, 0 to any power should be 0, but anything raised to the 0th power is 1. So what are we getting here? 0 or 1, that kind of idea. Same thing here. Any number raised to the 0th power is 1, but infinity raised to any power should be infinity. I don't know. And then infinity minus infinity. Well, that's just weird, because what's the magnitude of each of them? This could be infinite. This could be 0. This could be negative infinity, or any finite number in between. So those are all indeterminate forms. I want to quick point out some things that are not indeterminate. Not indeterminate, because it's really easy to get these things confused. Infinity plus infinity, there's no issue there. That's still going to be very big. Of course, negative infinity minus negative infinity, or sorry, negative infinity plus negative infinity would be negative infinity. So there's no difference there. 0 to the infinity, that's not an issue. That would, in fact, be 0. So infinity to the 0 is a problem. 0 to the infinity is not. And let's see here. Oh yeah. 0 to the negative infinity, which seems a little bit weird, right? Then you're looking at 1 over 0 to the positive infinity. And as it goes to 0, this is going to approach positive or negative infinity, depending on the case of what you're raising to a power. So this could be positive or negative infinity, or not that it's indeterminate, but does not exist. That's possible as well, if it's fluctuating up and down. So there are possibilities here. All right, so indeterminate forms, not indeterminate forms. And of course, if we have finite numbers, then there's no issue there either in evaluating limits. So how do we handle indeterminate forms? So really quickly, we'll take a look at some examples in just a moment, but essentially it works out to be that we can apply L'Hopital's rule, and L'Hopital's rule says this: if we have the limit if the limit as x goes to c, whether that's infinity or not, this c could be infinite, of f over g, if this is of the indeterminate form 0 over 0, then the limit as x approaches c of f over g, which we're looking at a quotient here, is equal to the limit as x approaches c of f prime over g prime, which is very interesting. So what we can do here is we can take the derivative of the numerator, derivative of the denominator. Remember, this is not the quotient rule. The quotient rule is much more complex than this. That you actually have to think about remembering. L'Hopital's rule is just derivative over derivative. So when it results in this particular form, we can do derivative over derivative. Now, the nice part is if I have something that results in 0 over 0, that's relatively easy to rewrite as infinity over infinity. So this applies to a lot of different things. And then we can also usually rewrite each one of these in some clever way for us to have something that's going to result in this indeterminate form 0 over 0. So we can use L'Hopital's rule to help us out in evaluating such limits. All right, so let's take a look at a couple of examples in our next video. I'll see you guys back in the office in just a minute.